Hey all, welcome back to the series of Java programming. In last program we have seen a for loop where we have tried to print a table of any number, let's say 2, 5. Now in this program we will see how we can find out whether a number is a prime number or not. Let's begin. We are using Eclipse here. So in this program, here is the class. Class is important, okay? Class keyword is there. This is the class name, public, okay, because this class will be accessible everywhere because of the public. And here this is the main method. Main method is the first point of execution from where the program starts executing. Main method, the whatever it is written inside the main method, that will be executed. So suppose we have to write a program to find out whether a number is prime or not. So what is the logic? Let's first find out the logic behind finding out the prime number. Let's say we have 2. First I'll make it comment. 2. Is it a prime number? Yes. Why? Because either it is divisible by 1 or by itself. Right? Any other number can divide it? No. Let's say we have 3. Is it prime number? Yes, because it is divisible by 1 and 3 only. And what is between 1 and 3? 2. Is 3 divisible by 2? No. That means this is also a prime number. Now let's talk about 4. Is this a prime number? No, because numbers between 1 and 4 is 1, 2, 3 and 4. So a prime number is a number which is either divisible by 1 or by itself, okay, not by the number coming in between. Only natural numbers we are talking about. So between if we are talking about 4, so the number comes is 1, 2, 3, 4. So 4 is divided by 2. That means this number is not a prime. Now let's talk about 5. Is this a prime? Yes. So the number which comes in between is 1, 2, 3, 4, 5. So 5 is divisible by 1? Yes. By 2? No. Divide by 3? No. Divide by 4? No. Is it divisible by 5? Yes. So the number divisible either by itself or by 1 is a prime number. So how do we decide? We are trying to build a logic here. So what we are doing, let's say for 5 we have to find whether it is a prime number or not. So what we are doing, we are traversing from, so 1 is common for all. Let's try to remove 1. So we are checking from 2 till that number, and if it is divided by any of the number which comes between that number and 1, let's say 2, 3, 4. If it is divisible, then that means it is not a prime number. If it is not divisible, that means it is a prime number. Okay. Let's take example of 6. So what all numbers we have here? 1, 2, 3, 4, 5, 6. So what is, according to our logic, the number between 1 and that number. So between 1 and that number for which we have to find out whether it is a prime or not. What are these numbers? 2, 3, 4, 5. So is this number divisible by any of the number? Yes. 6 is divisible by 2, also divisible by 3. So as soon as we find that this number is divisible by any of the number, let's say if it is divisible by 2, then we need not to check further, because this is not a prime number. It is decided here only, just by dividing by 2. Okay. So let's try to implement this logic in the form of code. Let's take a number n for which we have to find whether it is a prime or not. And let's try to take 4 first. And according to our logic, we have to go from 1 till that number, right? Every time from 1 till that number. So for that we have to run a loop for not 0 int I. From where we will start? We will start from So between 1 and that number we want. So we should not start from 1. We can start from 2 because all the numbers are divisible by 1. So let's start from 2 and I less than, till where we have to go, less than the number for which we have to find out the whether it is a prime or not. For example, here 6. So before 6, right, we have to divide and check whether it is divisible or not. So I should start from 2 and it will go till before 6. So I should be less than 6. We will not write 6, we will write the number n, right? And then I plus plus increment will be there, curly bracket open close. So first time I will be 2, I is less than n is 4. So 2 is less than 4, correct. I plus plus, this will happen afterwards, not right now. So right now I is 2, condition satisfied. 2 is less than 4, it will come inside because condition is true. Then what we have to do, we have to divide. What we are doing here in our logic, we are dividing every time, right? So 2 is here first time. So what we will do, we will divide. In this case our example is 4. So we got 2. We will try to divide this number by the number which we got, that is I, and this 4 is n. So what we will write, n divided by I. Will it work? Yes, definitely, because what we are trying to achieve right now is 4, which is our number, and the I, which is from where we are trying to divide, we are starting from 2. So first time it will be 2. So 4 divided by 2 we are trying to do here. So what is 4? N divided by I. I is first time 2. So now what we have to do, we can store it somewhere, okay? Or instead of storing, we can apply a logic if it is dividing. So in this case, let's say 4 is divisible by 2, correct? So is 4 a prime number? No, 4 is not a prime number because 2 has divided it. So if we put this in a if condition, right? We have already seen how if works. Let's remove this semicolon. If n is divisible by I, so how we check that it is properly divisible? Just like 4 divided by 2 is 4 divided by 2 is equal to 2. So it is properly divisible, no remainder, right? So for that we have a percent sign we can use, which we call as modulus. So n modulus I, if it is divisible, that means 4 divided by I, and modulus means remainder. So what is remainder? 0. If remainder is 0, that means it is properly divisible, correct? N is 4, I is 2. 4 divided by 2, is anything remainder? No. So this will give the remainder. Remainder is 0, correct. Okay. If remainder is 0, what we have to do? We have to terminate it instantly, right? Do we need to check further? No, we need not to check further, because if any number divides it, it is not a prime number, right? It is decided at that time only. So we will print as soon as it is divisible, that means remainder is 0. 4 divided by 2, remainder 0, equal 0. Yes, correct, 0. So we will print system.out.println, and what we will print? And we will print not a prime number, right? We will just give this message to the user that this number is not a prime number. Here we have decided that the number is not a prime number if it is divisible, right? If remainder is 0, that means it is properly divisible. That means the number is not a prime number, correct. How we will check for the condition where the number is a prime number? Actually, let's say it, for example, 5. So first time I will be 2, n will be 5. So here it will be 5 divided by 2. Is it so? How it will happen? N value will be 5. It will come here, for loop. Value of I will be 2, condition will be checked, 2 is less than n is 5, so 2 is less than 5, condition true. Okay, it will come inside because the condition is true. So in next line, if will execute. What condition is written inside the if? N modulus I equal 0. So what is n modulus I? N is 5 modulus I value is initially 2. 5 divided by 2. What is remainder? Remainder 1. And what here we are providing? 0. That means this part is giving remainder as 1 because 5 divided by 2 is not divisible. It will leave remainder 1. 2 2s are 4 and 1 remainder. Okay. But here equal we are checking. Is it equal to 0? No. Condition failed. So it will not go and print this statement. What will happen then? As of now, it will just come here. Nothing is written. Again, it will go up. It will increment the value. I will be 3 because earlier it was 2. 3 less than 5. Correct. 5 modulus 3 because n is 5. I is 3. So 5 divided by 3. Remainder is 2. Is it equal to 0? No. Condition failed. Come out. Again increment 4. Again. As soon as it will be incremented 5 is less than 5, condition failed, it will come outside. So how we will check the condition for a prime, whether it is a prime number or not? So we can apply here in else part, or we can apply another if condition. If I equal n minus 1. That means I will be, in this case, in 5, it will be 4 because 4 less than 5, condition true, then only it will come inside. 4 is equal to 5 minus 1. Okay. 5 minus 1 is 4, condition true. That means the number is prime. We will print here system.out print ln. It's a prime number. But here we are missing one thing. We have just this will be coming, this will be checking every time. So let's say as soon as it gets divisible properly and we got to know that it is not a prime number, we have to break the loop. Okay. So it will not execute further, because if it is divisible by one number, let's say for example 6, divisible by 2, yes, that means this 6 is not a prime number. Do we need to check with 3 also? No, because we have already confirmed by dividing 6 with 2 that this is not a prime number. That's why we have put a break here. Break means it will come out of for loop. For loop means this is the complete for loop. So it will come out of for loop, means it will come here. Though nothing is written here, so it will just terminate the program. Okay, so we will see how this is working. Let's check out the logic. N equal to 5. Okay, first time n is equal to, the value of n is 5. For loop will execute. I value is 2. I is less than n. That means 2 is less than 5. Condition true? True. It will come inside. If condition will be checked. What is the value of n? 5. 5 modulus I. I is 2. 5 modulus 2 means what remainder will it give? 5 divided by 2. 2 2s are 4. Remainder is 1. This is checking for the condition equal 0. Is it 0? No. This side 1, this side 0, not equal. That means this condition is not true. So it will not execute. That means these line will not be executed. So what will happen? It will come out of if. That means here. So it will come to the next line. Again, if condition is there. What condition is there? I equal n minus 1. What is I? 2. What is n? 5. 5 minus 1, 4. So this side 2, this side 4. Is it equal? No. Condition failed. Again, this statement will also not execute. Correct? Correct. Now it will come here. Since it will not execute, it will come here. It will see that this is the for loop here. No statement written, nothing will execute. So it will come again here and I will be incremented. What is I? Earlier it was 2, now it will be I plus plus means 2 plus 1. That is, its value will be 3. I less than n, that means 3 less than n, n means 5. 3 less than 5. Condition true? Yes, 3 is less than 5. Here, it will come here inside because the condition is true. It will come inside for loop. Inside for loop means inside this curly bracket of for. In line number 12, it will execute line by line as we already know. If condition is there, it will execute. What condition is there? N modulus I. N means 5, I means this time 3. 5 divided by 3. Any remainder? Yes, 2. This side 2. This side 0. 2 equal 0? No, false. Will this statement execute? No. These highlighted thing will not be executed because the condition is not true. What will happen? It will come to the next line. Line number 16. Here another if condition is there. What will happen? It will check for the condition. What is I? 3. 3 equal n minus 1. Again, n is 5 minus 1, 4. So value will be 4 this side and this side 3. Is 3 equal to 4? No. So this will also not be executed because the condition got failed. Right? Again, it will come here, nothing executed. It will see that for loop ended. Again, it will go up, increment the value of I. I will be, earlier it was 3. So I will be incremented by 1. It will be 4. Okay, here in this I plus plus. Now it will come here. From last, it will go here, increment it, and it will check the condition. I less than n. That means 4 less than n. 4 less than 5. Condition true? Yes, 4 is less than 5. It will come here. If n modulus I 5 modulus I is 4. What is remainder? 1. But this side 0. Will it execute? No. Because condition got failed. What will happen? It will come outside if. Means here. Another if condition is there. What is this? If I equal n minus 1. I is this time 4. N is 5 minus 1, 4. 4 equal 4. Is it equal? Yes. This side also 4. This side also 4. What will happen? Condition true. Whenever the if condition is true, it will execute the statement which is present inside if block. So what is if block? Here. The number of lines, whatever written between these curly brackets of if. Because the condition is true, it will come inside and will execute this statement. And it will print it's a prime number. Okay. And now it will come here. Again, it will try to go up. Value of I will be incremented. It will be 5 now. So here condition will be checked. 5 less than 5. 5 less than 5. Is it true? No. Condition failed. As soon as condition is failed, as soon as condition will be failed, it will come outside for loop. Outside for loop means outside this curly bracket. Because these curly bracket will only be executed when this condition is true, I less than n. So since this condition is false, it will come out of this loop. It will come here and nothing is written here, so it will be just terminated. Let's try to run this program and see the output. It is a prime number. Yes, 5 is a prime number because it is not divisible. Yes, 5 is a prime number because it is not divisible by any of the number between 1 and 5. Let's try to see for 6. Let's remove this comment. For 6, if we execute, it is saying not a prime number. That means 6 is not a prime number because it is divisible by 2, 3 also, right? So I think this is giving a correct response. Let's try to put 10. 10 is a prime number? No, because it is divisible by 2, 5. So yeah, not a prime number. Yeah. So I think logic is clear. If you have any doubt, you can put comments. I can explain in more detailed manner in next video. Do we really need to divide with all these numbers from 2 till the number, till less than the number? No, we need not to execute, and we can save unnecessary execution of the program. How we can do it? Let's say we have 6. So do we really need to go till 5? No, we need not to divide 6 by 5 or 4. So what we can do, if we divide it by 2, so it will be 3. If we go till third element also now, okay, then it will decide whether it is a prime or not, because more than half of this number, let's say 6 divided by 2 is 3. So 4 and 5 will never divide 6 in natural way, correct? Yeah. So that's why we are dividing the number by 2, and we will run the loop from 2 till the number divided by 2. So what changes we need to do in this case to avoid unnecessary condition? We can go till n divided by 2, and we can put equal condition here, that I should be less than or equal to n by 2. So here we have example of n equal to 5. Let's try to execute it. I is equal to 2. I less than equal to n by 2. N is 5. 5 divided by 2, actually it will be 2.5. But since I is an integer type, so only integer part will be stored and not the decimal part. So integer part is 2. So I less than equal to 2, and initially I is equal to 2. This condition is true because of the equal sign. So I is 2 less than equal to 2. So it will be executed once only. It will come inside n modulus I. N is 5. Modulus I is 2. So the remainder will be 1. This side 0. This condition will be failed. It will come here. I is 2 equal n minus 1. So now we have to modify this condition also, because we have changed it to n by 2. So here is we have I equal to 2. 2 equal n minus n by 2 if we do, and minus 1 we can remove because it will only capture integer part. So n is 5. 5 divided by 2, 2.5. But since this will contain integer part only, so it will be having 2. So 2 equal to 2, correct. It is a prime number. It will be printed. And we also need to store it in a temporary number. Okay. N divided by 2. And we can use this temp here. So temp will be containing, since this is an integer type, it will contain only the integer part. N is 5. 5 divided by 2, 2.5. Only 2 will be stored in temp because it is of integer type. So I initially 2 equal temp 2, correct? Condition satisfied, both side 2. This will be executed. It is a prime number. Okay, let's try to execute it. Yeah, it is a prime number. Let's try to check for 6 whether it is working properly or not. Not a prime number, correct. Let's try for 8. Not a prime number. Try for 7. It is a prime number. So our program is working fine. Maybe this last part of the logic is not that much clear. Let me try to repeat it. So what we are trying to do, let's say we have to find whether 6 is a prime number or not. So we have to divide the number starting from 2 till half of that number. Let's say 6 is here. So 6 divided by 2 will be 3. So we have to go from 2 till that number, till 3. So we will try to divide 6 by 2, then 6 by 3. So yes, it is divisible. That means it is not a prime number. So this will be decided at first half part only. We need not to divide 6 by 4 and 5 also, because this more than half of that number, if we divide it by 2 and more than half, that means more than 3, it will be 4 and 5. 6 will definitely will not be divided by 4 and 5 in a natural way. So that's why we have just divided it by 2, and we have just reduced the number of execution of this program in order to avoid wastage of memory and time. Hope you understood the concept. Keep revising, keep practicing. Thank you so much for watching.